Hello mathematicians, so we are on page 3 of unit 6 of solving quadratic equations. We are still looking at the solving quadratic equation method 1 of factoring, which was our last unit, so something we are familiar with. So just a few things, some reminders. First thing is that we want to make sure that our equation is in standard form. So as a reminder, standard form is a x squared plus b times x plus c, okay? And since it's an equation, we'll have it equal to 0. We want to make sure that our equation is factorable, so you want to be able to factor using any of the methods that we had from our last unit. So GCF, greatest common factor, dots, difference of two squares, and when we're looking at trinomials, we want to use our Xbox method. So after the problem has been factored, we will complete a step called the T-chart. You create a T-chart to separate the two parentheses. Remember, we want to find and solve for x, so we want to find the zeros. So with the zero property rule, which is on page 2 in our vocabulary for that day, we need to set them both equal to 0 and solve for the variable. And if you want to check the root, we could put it back in our original quadratic equation and see it would equal to 0. So today we're going to look at 1 and 2. And let me scroll up. Okay. So we're going to look at 1 and 2 today, and then you'll try 3, 4, and 5 on your own. So for the first one, it says find the roots. So if you're looking at vocabulary, the roots, we said yesterday that roots, solutions, zeros, and x-intercepts, all interchangeable words, basically asking you to solve for x. So looking at this, you want to make sure it's in standard form, which it is. And then we want to be able to factor. So looking at this, I would say the factoring method that I would use here would be dots. Okay, difference of two squares, because 64 I know is a perfect square, and 2 I could break in half. Also, the operation between these two terms is subtraction. So when I'm doing dots, what we'll do is we'll set our two parentheses. One will be with addition, one would be subtraction. I separate x squared, so I'll have x and x, and the square root of 64 is 8. Now, in order to find it, I would make my T-chart. So basically, I could just split this in half and have my T-chart. I would set both of these equal to 0. Okay, and then I'll solve for x. So inverse operation, on this side on the left, I'm going to subtract 8 from both sides. And I would have x is equal to negative 8. And over here, I would add 8 to both sides. And I get x is equal to 8. Okay, so these would be my roots, okay? And if we wanted to check, you would check one at a time. So I'm going to go down here, but I know you have more room in your notebook. So if I said when f is negative 8, into this equation, I would have negative 8 squared minus 64. And negative 8 squared is 64. So 64 minus 64 would give me 0. So when x is negative 8, that's horrible. When x is negative 8, we know that the y, the root, is equal to 0, okay? And I can also do the same thing here if I wanted to check. I'll do it. F is 8 is equal to 8 squared minus 64. 8 squared is 64, so 64 minus 64. And again, f of 8 would be equal to 0. Okay? Those are the x-intercepts right here. So looking for x-intercept, that means we're looking for when y is equal to 0, which is f here. Remember, f of x is a fancy way of saying y. All right, I'm going to erase this so we have some space for number 2. And now looking at number 2, it says find the zeros, okay? Again, these words are interchangeable. So I want to make sure this is in standard form, and if I notice this is not in standard form. So here I would have to subtract 35x from both sides, and I would have 5x squared minus 35x. And in this case, I see that there's a GCF between 5x squared and 35x, and the GCF here would be 5x. So I could divide each term by 5x, and I would have 5x, and I would have x minus 7. And those are basically my two factors, so I can make my t-chart. And I would set them both equal to 0. So 5x equals 0. And x minus 7 is equal to 0. And on the left, I would divide by 5. And x would just be equal to 0 in this case. And here, inverse operation, I would add 7. And say x is equal to 7. So my two roots are x is 0 and x is 7. And I could definitely check that if I were to plug it back into the original. So I would say 5 times 0 squared equals 35 times 0. And 0 squared is 0 times 5 is 0. So 0 equals 35 times 0 is 0. So that's a true statement. And I could always check for 7. So 5 times 7 squared equals 35 times 7. And 7 squared is 49. So 5 times 49 equals 35 times 7. And using my calculator, my bestie, I would say 5 times 49 is 245. And 35 times 7 is 245. Okay?